So today we're going to talk about inscribed angles in circles. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So in the circles with center G, minor arc DF right here is the intercepted arc for inscribed angle DEF. Okay, so here's angle DEF. Goes from D through E through F. Okay, the ED and EF are the chords that make it. The arc that it intercepts would be the end, have end points of D and F. And that arc right there, in comparison to this angle, the arc is twice the angle, or the angle is half the arc. Okay, so what I'm going to write on there is a little symbol note for that. So if the arc was 2 times x degrees, what would the angle be? The angle is half the arc. 2x divided by 2 would be x. So if that's x degrees, this is twice as big, and the other way around. If the arc is given, you can cut it in half and you get the angle. Now that's a little different than when we talked about central angles. So real quick, I'm going to draw a little circle for you and remind you that if this is 120, oops, I don't know where the 1 went. I forgot to write it. There you go. If that angle, say, is 120, then that is a central angle, and the arc measure equals the central angle. So that would be 120. This is different. Okay, do you see the difference? So this angle doesn't have its vertex at the center like this one. So this angle and this arc measure are the same. If I drew in that, you see how I'm ending at the same little radii there? Those same points? What would this angle be? It'd be half of 120, so it would be 60. Okay? Do we see the difference? This one has its vertex at the center. The central angle is equal to the measure of the arc it intercepts. The arc that this angle 120 intercepts is here. Okay? This angle is an inscribed angle. There's a different relationship. The inscribed angle is half the measure of the arc it intercepts. Okay? So, these are all examples of inscribed angles that are intercepting the arc AC. So this is the arc that's being intercepted on each one. Okay, oops, I don't know why that went straight. Okay, it's just different types of arcs intercepted by this inscribed angle. So here's your angle, ABC, intercepts that arc. So you see where the arc is, it's where the endpoints of the angle are. Or not the endpoints, the points on the circle that they intercept. All right, those are just examples of an inscribed angles. So then the measure of the angle equals 1/2 the measure of its intercepted arc. All right, let's move on to some problems with examples. We've got 36 degrees for angle ABC. We want to know the measure of arc AC. So since that's 36, our arc is 2 times 36. So the measure of arc AC is going to be 72 degrees. And number 2, the arc measure, K to L, is 62. So how big is angle N? So the measure of angle N would be 62 divided by 2, which is 31 degrees. And the last example here, you've got angle QPR is 113. It intercepts this big major arc, QSR. So that would be 2 times 113, which is 226 degrees. All right, so the measure of major arc QSR is 226 degrees. Anybody still need this? Okay. Also, if you've got 2 inscribed angles and they intercept the same arc, or intercept congruent arcs, then the angles are congruent. All right, I'm going to grab a highlighter. If you like highlighting, this would be a time. Here's what's going on here. This is a little bit busy looking picture, and that's why I'm going to color it, because my actual notes are in color, but you can't see that on a printed piece of paper because we print in black and white. So if you see angle ACB, the arc that it intercepts is arc AB. Then you have angle ABB. Well, it has A and B as those last letters also, so it intercepts the same arc. With me? Then you have angle AEB. Notice it begins in A and ends in B. It intercepts the same arc as well, which means all of those angles are the same size because they intercept the same arc. So all those angles are equal. That's what it's saying. All right, now over here, it says angle ACB. That one is intercepting arc AB. Angle ADB was also intercepting arc AB. And angle AEB was also intercepting arc AB. That's why every one of those angles are congruent. All right. Find each measure. In this diagram, I want to find angle U. Which one is it congruent to? Well, I'll show you how to tell. So I'm going to highlight angle U. It is angle TUW. That intercepts arc WT. What other angle intercepts arc WT? Another angle that has a W. Yes, go ahead. TVW. Okay. All right, because it intercepts that same arc, we know those angles are equal. Okay, so if this is 30, then angle U is also 30 degrees. Okay, now you might want to notice that these guys, see how all these lines intersect? These two angles are on the same side, if you will. Okay, they meet up at this same arc. Now, if I go in the other direction, what other two angles are congruent? Okay, so what angles have U and V in them? Angle UTV and angle UWV would be congruent. Okay, they intercept the same arc UV. All right, so we know those are equal as well, so our equation to find x will be 3x plus 4 equals 2x plus 9. We'll subtract 2x from both sides. We'll have x plus 4 equals 9. Subtract 4 and find out that x is 5. Then we can plug 5 back in for what the expression is on angle T. We'll do 3 times 5 plus 4. That's 15 plus 4, so angle T would be 19 degrees. And I'm not saying that's the scale. All right. The next part about inscribed angles is actually inscribed polygons. An inscribed polygon is one whose sides are chords of a circle and whose vertices are points on the circle. So let's make our own over here. I'm going to do 5 points around this circle. Now, I didn't try to space them evenly. I just made 5 points. And now I'm going to connect them with little straight sticks or segments, which are chords. what I end up with is an inscribed pentagon. Why is it a pentagon? Because back in chapter 6, we learned that a 5-sided figure was called a pentagon. All right, and I just made that up. I just was trying to show you how you could make one real easily inscribed. Now that one doesn't have any special properties, so here's the ones we really want to know about. If you have an inscribed triangle and it intercepts the diameter of the circle, then it has to have a right angle. And the converse is also true. So, an inscribed angle of a triangle intercepts the diameter or semicircle only if it's a right angle. Well, why would that be? And I'll explain. Angle BCD, it says, is 90. And the reason it's 90 or it's only 90 if it intercepts that diameter BD. Well, here's the reason. This is intercepting half the circle. How big is half a circle in degrees? Isn't that 180? And this angle is an inscribed angle. It would have to be 90 because it's half. That's what half of 180 is. Okay? So you really don't have to know this theorem to get it. Okay? But since B to D is a diameter, we know that has to be a right angle. What other angle in this diagram must be a right angle? Okay, so right here, because we're going to have another right angle right there on angle BAD. So if angle arc BCD is a semicircle, which it was, BCD is a semicircle, then the measure of angle BCD is 90, and so is the measure of angle BAD. Bless you. And if you think about it, going this other way, angle BAD, it just intercepts the other half of the circle. So that's 180. So that angle had to be half of 180, which is 90. Okay, the other property you want to know is that if you have an inscribed quadrilateral, 4-sided figure in a circle, opposite angles are supplementary. They add to 180. So angle A plus angle C is 180, and angle B plus angle D is 180 as well. They add to 180. They are not necessarily equal. Is necessarily have 2 C's or 1? Is it I know it's 2 S's, right? Oh no, I'm trying to remember. Is it 2 C's? 1 C and 2 S's, right? Not necessarily, that doesn't even look right, equal angles, okay? Don't assume they're equal angles. Okay, they add up to 180. Do not think of them as being equal. That's not, you know what I mean? Because that's not a parallelogram, which did have opposite angles are equal. All right, that's why I'm trying to mention that. Okay, don't assume that they're equal. They just add up to 180. Here's our examples. In this diagram, since angle WYX intercepts the diameter or intercepts a semicircle, then that means angle Y is 90. Okay? Then we can say this triangle's angles add up to 180 because we've been doing triangle angle sum theorem forever. So we're going to have x plus 12 plus 90 equals 180. Simplifying gives us 2x plus 102 equals 180. Subtract 102 from both sides. We've got 2 times x. My pen's stuck. Second, 2 times x equals 78. We would divide both sides by 2 and get x is 39. All right, and then it asks us to find angle W. So that would be 39 plus 12, 51 degrees. Okay, and then using the other concept of opposite angles are supplementary, if you have an inscribed quadrilateral. It says UPSR is an inscribed quadrilateral. Find x and y. To find x, angle U plus angle S equals 180. Substituting for angle U, 3x minus 5, plus substituting for angle x, 3x plus 5 equals 180. Carolyn? Oh. Okay, then you would add your x's. That'd be 6x. And minus 5 plus 5 is 0. So we got 6x equals 180. Divide by 6, and x is 30. You could go back and find the angles by plugging back in. All right, next we're going to find y, and that's going to be done because angle R plus angle T equals 180. So I do 11y plus 7y equals 180. 11y plus 7y is 18y. And then we would divide by 18, and we would know y is 20. Pardon me. I think that's it for the ISN, right? All right, so we're going to go to our packet now. Not on your packet, this picture, but I want to, again, reiterate. That's the center of the circle, and this box is a right angle, which would mean it's 90 degrees. The arc would be 90 degrees. What would this inscribed angle be? See how this is a lot bigger, and then this is a lot pointier? It would have to be half of 90, so it would be 45 degrees. Okay, now I realize you don't have that in your ISN. I just wanted you to remember the measure of the arc is equal to its central angle, and the inscribed angle is half of the intercepted arc. That's what this stuff says. Let's jump to the problems, because I think unless you would like to do any highlighting on here again, all of those angles are congruent because they intercept the same arc AB. Okay. In the circle with center G, if arc F is 90, find angle DEF. Well, it would be half of 90, so it would be 45 degrees. Good. Number 2, find the measure of arc MP. I tell you, sometimes on quizzes and tests, I just want to go crazy because the reason we missed some questions is simply because we didn't read. Are we asking for arc MN? No. Do I need to find my arc MN? Yes. Okay, now I don't like that this picture didn't show that the center of the circle is there, that actually PN is a diameter. There's no way to solve this problem unless we have that info. So please mark the center. Now, MN is double the angle because that's the inscribed angle that intercepts arc MN. So this would be 62 degrees. MN. Now we're going to get PM by doing the fact that PN is a diameter. That's a semicircle. So arc M to P is going to be 180 minus 62. So it's 118 degrees. How am I going to find the measure of angle R? I want to know this, so I need to know arc QS. So I can divide it by 2. How am I going to figure out arc RS? Some ideas, please? Arc QS, excuse me. Okay. Thank you for raising your hand, Cadence. I was going to ask you. It's all right. Do you want to say it? He was going to say the same thing. So Darylyn said, add those two angles, right? Which is 260 and subtract from 360. So since the sum of all three arcs would be 360, 120 plus 140 is 260. So we'll subtract 260 from 360 and get what remains is 100 for arc QS. And then we can quickly get angle R by dividing 100 in half and get 50. Number 4, we've got a picture over here, and I can see that angle ABD and ACD intercept the same arc. Since they intercept the same arc, then these angles are congruent. So I'm going to set 7x minus 11 equal to 6x minus 3. All right, now I solve by subtracting 6x. I get x minus 11 equals negative 3. Careful to bring that negative with the 3. And then I would add 11. So I subtracted 6x. And now I'm adding 11. I get x is 8. Negative 3 plus 11. Next, I can find the measure of angle C by plugging in 8 back in. 7 times 8 minus 11. That's going to be 56 minus 11, so it's going to be 45 degrees. How am I going to find angle Y? Well, let's look at it going this way. This angle has a 6y minus 2 on it. This one has a 5y plus 8 on it. Those angles are equal because they both intercept arc BC. This one intercepts arc BC as well. So this angle is equal to this angle. So 6y minus 2 is equal to 5y plus 8. Subtract 5y from both sides. Y minus 2 equals 8. Add 2. And we get 10. I believe there is no typo on the worksheet. I believe we fixed it. Does it say find the measure of angle A? On your worksheet, it doesn't? Yeah, I think we fixed it. So measure of angle A, plug back in. We got 10, so it's going to be 6 times 10 minus 2. That's 60 minus 2, or 58 degrees. All right, inscribed polygons, we already discussed that this would have to be a right angle and this would have to be a right angle because they both intercept a diameter. Okay, and then I don't really need to go back over these again, except that angle A plus angle C would be 180, and so would angle ABC plus angle ADC. Let's move on to the first example. Find the measure of angle K. Well, first off, it says KL, our KL equals our KM, which would tell me the chords. This is back from 10.3. If two arcs are equal, then their corresponding chords are congruent. So this would be KL, segment KL would be equal to segment KM. The triangle is isosceles, therefore angle L is congruent to angle M. We can put 3x plus 5 on angle M then, just like angle L. And the angles of a triangle add up to 180, almost at 360. We had 3x plus 5 plus 3x plus 5 plus 5x plus 5 equals 180. Add up your x's. That's 6 plus 5, 11x. And then 3 5s would be 15 equals 180. Subtract 15 from both sides, and we get 11x equals 165. Divide by 11, and x is 15. All right, and then it said find angle K. The measure of angle K is going to be 5 times 15 plus 5. Calculate that, please. All right, so we should have gotten the measure of angle K is 80 degrees. All right, now we already did this problem. So if you've been paying any attention and you've been focused, you should know how to do this question. Based on this picture, what do we know? Angle Y is 90 degrees. Okay, yes, why? And this is really important, you guys, for you to even be getting what's going on. If you've just been going through the motions and writing stuff down and you haven't been calculating or participating with the problems, you're not learning. So I'm hoping that you have been, because that's the only way you're going to get that physical memory. Why? Can someone explain why that angle Y is 180, Evan? Good. Oh, I totally, you know what you're talking about. I'll try to articulate it a little bit differently. Just make sure everybody's followed what you said. So you got angle WYX. He said that cuts off an arc that's half a circle, right? And half a circle, he said, is 180. Okay, this angle is an inscribed angle. Its vertex is on the circle. Therefore, it's half the measure of its intercepted arc. So this has to be 90. That's why. I want you to understand that this has endpoints, or when you name the angle, the 2 points that you name first and last indicate a diameter. Okay? All right, so what is my equation I'm going to use to solve? Can someone else tell me an equation to use to solve for x? All right, Kylie? Okay, the angles of a triangle add up to 180. Or you said x plus 12 equals 90, didn't you? Did you say 90? Oh, you said plus 90 equals 180. Good job. All right. Now, if anybody did do x plus 12 plus x equals 90, that'll work because there's only so much left. There's only 90 left for those two angles. All right, 2x plus 102. This one we did in our ISN. So this is the second time we're doing this exact problem. All right, so we got 2 times x equals 78. All right, what is the angle measure of x? What size is x? 39. Okay. And that was an angle, 39 degrees. The measure of angle W is going to be 39 plus 12, so it was 51, just like on our worksheet. So, the next problem. Tell me what you know based on what you see. I need somebody to give me some information. What am I going to do for this problem? Angel. What do you know from the diagram? Then you didn't pay any attention to the last question, so I don't want to be, you don't know how to say it, maybe? Okay, sweetie. All right. What would you write for an equation then? But wait, that's only 2 angles. You're headed in the right direction. Yes. Okay, what angle was 90? Or is 90? That's what I need you to know. So if you have this angle right here, it's intercepting half of a circle. That circle's half is 180. This angle is 90 because it's half of that arc. All right, that's why this angle is 90. These angles then add up to 180 because the angles of a triangle add up to 180. All right, so let's see what we got. 6x, negative 6 plus 90 would be plus 84 equals 180. Finish solving that, please. $16, thank you. All right, then it says find the measure of angle T. So we're going to do 4 times 16 minus 6. And that's 58 degrees. All right. Looking at number 12 and 13 for this diagram, there's more than one way to get this job done. So I could have someone tell me how to find the angles probably 3 or 4 different ways. Marilyn? You could do 3x plus 75 equals 180 because opposite angles are supplementary. But guys, what's supplementary mean? They add up to, don't I already know what angle R is then? If this is 75? Yeah, you can just do 180 minus 75 and you've got the answer, 105. You don't even have to find x. So let's do that quick for the other one. Q and S add up to 180. Why bother finding x if all you want's angle S? How big's angle S have to be? 180 minus 110, so 70 degrees. Now, the next question, you can't do that. You see what I'm saying for this one? Now, you could have solved this and found x and then plugged it back in, okay, but it would have just taken longer. This particular problem was quicker to do by saying, I know those add up to 180. Angle S is to be, 180 minus 110. All right, next one. This one, though, we have to find x, and we have to find y. All right, so let's get an equation, please, for how to find x. These two add to 180. Okay, you do not set them equal, never. You're going to say they add up to 180. So 2x plus x plus 18 equals 180. 2x and x is 3x. Okay, this is what you need to solve. Continue. Okay, so what did you get? 54? All right, now it said to find angle W. So we're going to need to do 54 plus 18, and that's 72, isn't it? Okay, now to find x, we are going to have to use the fact that angle x plus angle z equals 180, and I'm writing that real loosely where it should be the measure of angle x plus the measure of angle z is 180. So I'm going to pop in 3y minus 7 plus 3y plus 1 equals 180. Okay, I got 6y minus 6 equals 180. Finish it. And I found out a lot of people make a boo-boo right here because they subtract 6 instead of adding. Okay, you want to do 180 plus 6 and then divide by 6, so you should get 31 for y. All right, and then you need to plug that back in. Do 3 times 31 minus 7. It's 93 minus 7, so it should be 86. Thanks. Okay. The next part, of course, is the homework. You need to practice. And there's one in particular I think we should just go right to and talk about because It will never fail that I will be asked that question. It's a word problem. And it's the second number 23. I do not know why there are double 23s. Let's quick just look at this together. It's just that it's so confusing when you read these wordings, so I'm going to go nice and slow with it so you'll understand. It says 3 kilometers separate the intersections, that's plural, of Cross and Upton. Cross and Upton would be up here. The other intersection is Cross and Hope. Cross and Hope would be down here. And it says that that's 3 kilometers apart. So that just means this is 3. Then it says, what is the distance between the intersection of Upton and Hope? Upton and Hope would be here. And the point midway between the intersections of Upton and Cross, which is here, midpoint between Upton and Cross and Hope. That'd be the midpoint of this segment. And what is that? I want to know this length. It's a radius, isn't it? And isn't this a radius? And this a radius? And how big are those radii? Half of 3. 1.5, 1.5. This is another radius, 1.5. So they're 1.5 kilometers away. That's what I wanted. If anybody else spots something right now, I can go over it. Otherwise,